Unit 5, pages 152 to 155, Applying Theorems in Calculus. Intermediate value theorem, extreme value theorem, Rolle's theorem, and mean value theorem. So IVT, EVT, Rolle's theorem, and MVT. So before we begin, let's remember what each of these theorems say about a function. So intermediate value theorem, in other words, IVT, states that if f of x is continuous on the closed interval a to b, and f of a is less than y, which is less than f of b, or f of b is less than y, which is less than f of a. In other words, if y is between f of a and f of b, then there is at least one value of c on the open interval ab such that f of c is equal to y. Okay, so intermediate value theorem, we learned that in Unit 1. We're coming back to it now with all the rest of our theorems. Extreme value theorem, in other words, EVT. If f is continuous on the closed interval AB, then there must be an absolute minimum and an absolute maximum on the interval AB. These absolute extrema can occur at the endpoints of these intervals, so at x equals a or at x equals b, or any critical value of f on the closed interval a comma b. Okay, so IVT and EVT only deal with continuity, really, right? So if the function is continuous, then these things hold true. Rolle's theorem and mean value theorem need a little bit more than just continuity to prove them. So if f of x is continuous on the closed interval a to b, differentiable on the open interval a to b, and if f of a is equal to f of b, then there is guaranteed a value of c on the open interval ab such that f prime of c is equal to 0. And the mean value theorem, also known as MVT, states that if f of x is continuous on the closed interval ab and differentiable on the open interval AB, then there is guaranteed to exist a value of C on the open interval AB such that f prime of C is equal to f of A minus f of B all over A minus B. So in other words, the instantaneous rate of change of C is equal to the average rate of change on the interval. Both Rolle's theorem and mean value theorem deal with continuity and differentiability. The only difference between the two is that Rolle's theorem also needs f of A to be equal to f of B to prove that there is a zero in the derivative. Okay, so knowing everything we know about those four theorems, we're going to use that information to help us answer four different types of problems. So the first problem we're going to look at says the rate at which water flows out of a pipe into in gallons per hour is given by a differentiable function r of time t. The table below shows the rate is as measured every 3 hours for a 24-hour period. So what we know is that we have a differentiable function. And if we have a differentiable function, then this implies continuity. So it implies that the function is also continuous. We know that our units are in gallons per hour, which is already a rate, and water is flowing out. We want to estimate the value of r prime of 5, indicating correct units of measure, and explain what this value means about r of t. So if we're estimating the value, normally this would be an instantaneous rate of change. However, because we don't have an equation and we're estimating, we're actually going to use average rate of change for the value right below and right above 5. So r prime of 5 is approximately going to be equal to r of 3 minus r of 6 all over 3 minus 6, which is approximately 10.4 minus 10.8 over negative 3, which is approximately 0.133 gallons per hour right? So because our units are gallons per hour already, and we're taking the rate of that rate, so we have gallons per hour, which we can rewrite as just gallons per hour squared. And this means that since r prime of 5 is greater than 0, the rate at which water is flowing out of the pipe is increasing at time equals 5 hours. All right, so now using correct units of measure, we want to find the average rate of change from t equals 3 to t equals 18. So our average rate of change can be found by taking r of 3 minus r of 18 over 3 minus 18. So 10.4 minus 10.7 over negative 15, which is equal to 0.02 gallons per hour squared. Okay. Is there some time t between 0 and 24 such that r prime of t is equal to 0? So this statement, or this question, is basically asking us, can we apply Rolle's theorem? Right, so we're looking for some value within an interval such that the derivative of that value is equal to 0. That is Rolle's theorem. So in order to prove Rolle's theorem or apply Rolle's theorem, we have to make sure that our function is continuous on the interval and differentiable on the interval. And as stated above, we know that r of t is continuous and differentiable on the interval from 0 to 24. Okay, and the next thing we need to know is f of 0 and f of 24. We want to make sure that those are equal. So going back to the top, f of 0 is 9.6, and f of 24 is also 9.6. Therefore, Rolle's theorem guarantees a value of t on the interval from 0 to 24 such that r prime of t is equal to 0. All right. For our next problem, we are given an equation. And we want to figure out a few things. So we know that the total order and transportation cost measured in dollars of bottles of Pepsi Cola is approximated by this function, where X is the order size and number of bottles in hundreds. Answer the following questions. Okay. So first thing I want to do is I want to rewrite this equation so that it doesn't have multiple fractions in it. So this can be rewritten as 10,000 times, right? To get a common denominator here, multiply that first fraction by x plus 3, multiply the second fraction just by x. So we get x plus 3 plus x squared over x times x plus 3. All right, So first thing we want to know is there guaranteed a value of r on the interval from 0 to 3 such that the average rate of change of cost is equal to the derivative of r? So this question, we're given an interval and we want to know if the average rate of change is equal to the derivative. This question is asking, does the mean value theorem apply? And going back to what needs to be true in order to apply the mean value theorem, we need to make sure that the function is continuous on the closed interval and differentiable on the open interval. So first thing we want to know, is the function continuous on this closed interval? The values that would make this function discontinuous are x equals 0 and x equals -3, because the denominator will equal 0. Okay, so because we want to make sure that the function is continuous on the closed interval, which means when I plug in either one of these two values, 0 or 3, I should get an answer. We know that's not true. So since C of R is not continuous on 0 to 3, MVT does not guarantee a value of R on this interval such that C prime of R equals C of 0 minus C of 3 all over 0 minus 3. Okay. Part B is asking, is there a value of R on the interval 3 to 6 such that the derivative of R is equal to 0? This is now asking us, does Rolle's theorem apply? And it's giving us a different interval, so we can't just assume that since MVT didn't apply above, that Rolle's theorem won't apply here. All right, so we know that C of x is equal to 10,000 times x squared plus x plus 3 over, and if I multiply this out, we get x squared plus 3x. So C prime of x, using the quotient rule, we get 10,000 times x squared plus 3x times 2x plus 1 minus 2x plus 3 times x squared plus x plus 3 all over x squared plus 3x squared. That's my derivative. All right, so the only values that will again make this function discontinuous are the values of 0 and -3, neither which are on my interval. And the only values that will make this discontinuous are 0 and -3, which are not on my interval. So since C of x is continuous on the closed interval from 3 to 6 and differentiable on the open interval from 3 to 6, we can now look into this final step. Right, so Rolle's theorem, we need continuous and differentiable. And we need the values of the intervals to be equal to each other. So C of 3, if we plug that into a calculator, we get 8,333.33. And C of 6, we get 8,333.33. So it's continuous, it's differentiable, and C of 3 is equal to C of 6, which is equal to 8,333.33. Then Rolle's theorem guarantees a value of R on the interval 3, 6 such that the derivative of R is equal to 0. Okay, so if I graph this derivative function and find its zeros, we'll see that C prime of R is equal to 0 when R is equal to 4.098. So that's from our graphing calculator. Okay. Final question on this page. For the closed interval 3 to 9, what's the greatest cost for order and transportation? So looking for greatest cost for order and transportation, this is an extrema. So this is asking us, does EVT apply? Can we use EVT to do this? And we can, right? Because our function is continuous, we can use EVT to help us out here. All right, so EVT, since our function is continuous, we know that we're looking for an extrema at either the endpoints of our interval or at the critical numbers in our interval. And this interval only had one critical number, which was 4.098, because that's when our derivative equals 0 on this interval. So at C of 3, we know our value is 8,333.33. C of 9, just plug it into a calculator, we get 8,611.11. And C of 4.098, we get that our value is equal to 8,213.67. So the cost for the greatest order and transportation on the interval 3 to 9 occurred at x equals 9 and was $8,611.11. All right, the next two problems, which are the next two pages, we're only going to do parts of together, and you're going to figure out the rest on your own. So for the next problem, we have a car company that introduces a new car for which the number of cars sold is modeled by the function S of t equals 300 times 5 minus 9 over t plus 2, where t is time in months. Find the value of S prime of 2.5. Using correct units, explain what this value represents in the context of this problem. Okay, so for part A, we're just looking for the instantaneous rate of change, which is just the derivative. For part B, we want to find the average rate of change of cars sold over the first 12 months. So this is asking us for the interval from 0 to 12, find the average rate of change. Indicate the correct units of measure and explain what this value represents in context. Part C is asking, is it possible that a value of C for the interval 0 to 12 exists such that the derivative of C is equal to the average rate of change? So here we have an interval, and we're being asked if the derivative of a value is equal to the average rate of change. This is asking us, does the mean value theorem apply? And if it does, then identify the value of t, or C. Okay, so what I want you to do is take a crack at those three problems on your own. See if you can figure out A, B, and C. All right, and that is the end of our video, and I will see you all tomorrow.